So today we present Sriboya, southern Thailand, constructed wetlands. Introduction. Sriboya Island is located in the Andaman Sea archipelago on the west coast of southern Thailand. It is a beautiful tourist destination having exceptional marine biodiversity and marine wildlife. However, developing Southeastern Asian islands and communities like Sriboya has a history of limited water and wastewater treatment, as these small southern Thailand islands continue to grow in the tourism sector. Their capacity for treating higher BOD effluent flows must increase to avoid ecological degradation. So this is the location of the island in Thailand.
So we chose to put the water treatment plant up at one of the highest points due to us using a gravity flow for treating the wastewater. And we would use pumps to pump everything up to that point. And it's roughly centralized on the island, so everything would be coming to the center point.
Current method of wastewater treatment. There is a very limited method of treatment on the island, and the majority of sewage is discharged directly into the surrounding waters. There are currently no enforceable regulations governing the construction of septic tanks and latrines on the island. Sewage from private residences is either sent to poorly constructed pit latrines, septic tanks, or discharged directly into the sea. Most of the wastewater simply accumulated within the lowest part of the sewer line and never fully reached the treatment plant. Local regulations require that hotels and resorts with more than 90 rooms build their wastewater treatment facility. Many owners manage to avoid these regulations by building just under 90 rooms and then discharge untreated waste into the ocean. Our proposed treatment system. To prevent another disaster like such on Phi Island and other surrounding islands among Southeastern Asia, we require wastewater management systems that are multifunctional and self-sustaining, providing benefits to the livelihoods of the municipality, landowners, and residents of the region.
So what is a constructed wetland? Our research suggests that amongst these small island communities off the coast of Thailand, the best practices of wastewater management point towards constructed wetland systems. We propose that a constructed wetland project developed for the neighboring island of Koh Sriboya can effectively act as a treatment plant while also integrating components of a public park into the area. It will be a multifunctional public area complete with walking paths and gardens. The wastewater, instead of being discharged into the local waterways, could be used for irrigation and agricultural purposes. So our primary constraints and considerations are land scarcity, a bit of limited slope, energy scarcity, as well as primarily water scarcity. So a 3,000 meter squared plot is the only area of land owned by the municipality, and the rest is all divided between private residences and also tourist areas and other park regions. Our plant must be built within this constrained region, and our plot of land is also in relatively close approximation to the island's main tourist routes and some traffic routes as well. So it must be odor-free, or it should be relatively odor-free, and maintain the aesthetics of the region in order to maintain tourism attraction. And there are also challenges for upkeep and maintenance, as there are only about 1,000 permanent residents on the island. It will be difficult to find people to operate and maintain a very advanced plant. And also due to water scarcity, the treated wastewater should be reusable as a secondary water resource instead of being a potable source of water for drinking. So it will be mostly used for irrigation and agricultural purposes. So for budgets and our sources of funding, we have proposed an initial budget of 17 million Thai baht, which is approximately 425,000 US dollars for the initial construction, as well as all post-supervisory costs. Now, this may include post-operational budgeting, covering maintenance costs and operational issues, and our need to hire supervisory wastewater management experts, and also to train new employees. The budget for this wetland could come from the tourism industry. That means nearby hotels and travel agencies, as it will help to support the tourism industry because it won't have a typical wastewater facility look, and it will be instead incorporated into the landscape, and it will look like a park instead of not like a wastewater treatment facility. We could also get funding from the World Health Organization, environmental organizations, NGOs, and environmental protection agencies. They could be a source of funding because our wastewater effluent on the island will no longer be mostly direct or released into the ocean without any sort of treatment. So it will be treated first to standards and then released into the ocean. So it will protect the environment and ecosystems. So our realistic treatment goals, we hope to meet the following standards: pH 5.5 to 9, total suspended solids less than 50, BOD will be less than 20, and total Kajal nitrogen will be below 100. Oil and grease hopefully will be below 5, and fecal coliforms are of course 0. We do need to recognize that possible areas of concern may be oil and grease due to the high capacity of hotels and restaurants and tourist areas in the vicinity, and also because there are limited regulations preventing these owners from placing oil, discharging oil into the system as well. And go back. And we also do not have a fully activated sludge process, complete with an aeration tank that's typically used for the full removal of oil and grease within our wastewater. So that's something we need to be cautious of. Okay. So our design details, this is a primary schematic of all of our design steps or treatment steps. So for our capacity, it'll be about 250 meters cubed a day. The influent BOD will be 50 milligrams per liter. Total Kajal nitrogen will be about 7 milligrams per liter. And the most effective component of this, most treatment will be occurring within the vertical flow you see there, right after the distribution tank. That will be a trickling filter, and about 80 to 90% of our treatment will be occurring within that area. We've chose to do a primary vertically flowing trickling filter because it has low energy requirements, low maintenance, and a small footprint as well for the island, and it also has a high treatment capacity, like mentioned before. So yeah, distribution tank will flow to 2 vertically flowing lines of treatment, and then that will then flow into a horizontal flow, and then a free surface water flow to a disinfection pond, and then a reservoir, which we can then reclaim our water for irrigation and agricultural purposes. Okay.
So sedimentation. All wastewater will be collected through a gravity flow wastewater from all toilets. Will be collected pre-treated within local septic tanks. Effluent would be discharged into a closed-loop small pipe system that is completely independent of stormwater drains and gray waters. This system will prevent any backups from happening and from an overflow of the septic tank or from the sewage tank pipes when there's a high flow of water. coming through. It will also ensure that there's a consistent level of BOD coming up to the plant. The pumping station intake is doused using a siphon instead of an electrical pump, which works entirely on hydraulic principles and solar power. It can be equipped with an odor control unit as well. We would also want to employ a skimmer/oil separator used to separate oil and grease from the effluent located at the pumping stations. Some maintenance would be required for this, but it would be very minimal. Then we would have the screening station. So for the vertical flow constructed cells, it has a high treatment capacity with a small footprint and low maintenance cost requirements. Water flows from the inlet of the reservoir through 2 to 3 siphon ponds, which eventually distributes the wastewater to the entire top. Acts as a trickling filter/gravity filter, so it puts down the water evenly through the trickling and filter, and just using gravity to feed it through. The media is sprayed with microorganisms to promote flocculation.
Flocculation.
Flocculation. There'll be 3 different types of gravels used to ensure that we're getting all the way down to a small enough size. And the majority of the treatment will occur in this spot. It would be 80 to 90% occurring right here from the influent coming in. The maintenance requirements is little to no maintenance requirements, which is why we chose this design. And we would have these ponds or wetlands at around 1,000 square meters to approximate depth of 3/4 of a meter from the outlet at the bottom of the vertical tank. The water flows through the horizontal surface flow into the wetlands. So from the vertical into the horizontal flow. So this is our station where all the effluent would come in. It would go into the vertical flow, into these leaf-looking like things. And those are actually the wetlands where all the effluent would be coming in and be 90% treated. And then it would flow out and into the horizontal here. And then it would go into the
subsurface flow.
Subsurface flow, that's it.
Yeah.
And then it would go into the ultraviolet flow here, and then it would be into a reservoir after that for pumping into irrigation.
Yeah, and that final UV clarification pond, it will also be like a secondary clarification, just used for the final steps.
So the horizontal filtration, we decided to include a horizontal filtration because in addition to a vertical, it's a safeguard in case operational issues with the vertical system. The horizontal filtration also requires little to no maintenance and is more reliable than the vertical flow. The vertical flow can do 2 to 3 times more effluent than the horizontal flow can, but the horizontal is more
reliable.
That's it.
And I just want to jump in quickly here and just say that the vertical system, in terms of operational issues, that comes from difficulties in maintaining even distribution through all the siphons. So we want to evenly distribute all of our effluent across the entire surface of the vertical wetland. But that typically we can run into issues with that, and not the entire top may be covered. So not all will gain adequate treatment. So this is why we have decided to implement the horizontal filtration as well. Sorry, go ahead.